In chapter 7, section 2, our goal for today is to estimate a population proportion. Well, what does that mean? It means to estimate a population percent, the percent of the population that maybe lean toward a certain side, maybe the percent of the population that votes Democrat, the percent of the population that watches basketball, and so on and so forth. So, unfortunately, we won't be able to get an exact number, but we're going to use our sample size. We're going to use a sample of the population to estimate the true population, all right? And that's what estimating population proportion means. Proportion refers to percent. What percent of the entire population does this or does that? Let's take a look at an example that leads us into our population proportion. A survey of 4,000 adults found that 45% of the people who were offended by a TV program would change the channel. So we want to know maybe how many people in the population actually change the channel. We can't ask everyone because it's too expensive. Therefore, we do a survey of just 4,000 people, and then we use this number, which is a proportion. We call this a sample proportion because it's just a proportion of our sample, right? Remember, think of the word proportion as percent. So we use this number to estimate our true population. So as we're reading this, the survey also stated that the margin of error is 3%. So from reading this one survey, a few things that come up. How do we know that? How close does our true proportion compare to our sample proportion? Right? And what is the meaning of this 3% error? We call it a marginal error. We're going to go deep into those a little bit later. So in today's lesson, we will discuss on how to estimate the true number, the true population proportion that lean toward a specific proposition. Right? We will discuss about how to find this error because as you're estimating something, there's always an error, and we want to know how we find this error so that we can get a precise look at our true proportion. Definition. So before we start, there are a few terms that you will need to know. The letter P right here stands for the percent of the population or the proportion of a population that lean toward a specific number. Unfortunately, we will never know the true value of P because that's our proportion population, our percent population. Remember, the word proportion and percent can be used interchangeably. So to estimate the true number, to estimate P, a random sample should be chosen. So we choose so many people to try to estimate the true number. And then P should be estimated by the proportion of the sample. So whatever we get in our sample, we use that to estimate the true number. All right. We call this estimator P hat. So P hat is just P hats estimate P. Right. We don't know what P is, but we use P hat to estimate P. P hat is the data from our sample. So like in this example right here, 45% would be our P hat because that came from our sample of 4,000 adults. How do we find P hat? Well, to find P hat, we look for the number of members in our sample that lean toward a specific proposition, and then we divide it by the sample size. So if we were looking at this case, our sample size would be 4,000, right? And 45% of that is kind of like the number of people that would change the channel, and that's how we got 45%. Okay, so X represent the number of members in the sample who leans toward a specific proposition, and N is the sample size. The complement of people who lean toward a specific proposition is people who don't lean toward that, and we call that Q hat. There is a relationship between Q hat and P hat. So Q hat is 1 minus P hat. Okay. All right. So in first example here, let me show you how to find P hat and Q hat. In a survey of 150 households, 60 have air conditioner. Find the estimator P hat and Q hat. So our sample size is 150 because we survey 150 households. The number of people that says yes, they have air conditioners, are 60 of them says yes. So our sample proportion, or the estimator for the population, which is p hat, is equal to the number of people who says yes over the sample size. So it's going to be 60 out of 150. Okay, and Q. Okay. And by the way, we can actually find what 60 over 150 is. So if you take 60 divided by 150, then you get 0.4, right? So this is 0.4. So 0.4, or 40% of the sample has air conditioner. And so if you take 1 minus p hat, which is 1 minus 0.4, then that gives you 60. All right, so 60% of the sample do not have air conditioner. Very good. Yale communicologist trying to determine if a student's reaction to the new building of a new parking structure. To do so, the school selected a random sample of 50 students. So they asked 50 students and questioned them, and if 20 were in favor of building a new parking structure, so 20 of them were in favor of building a new structure, estimate the proportion of students who are in favor and who are not in favor. So our sample estimate would be like the number of students who says yes out of 50. Okay. So 20 divided by 50. We're looking at 0.4 again. Okay, so 0.4. And then if P is 0.4, then Q, which is equal to 1 minus P hat, that would be 1 minus 0.4. That would be 0.6. So we can conclude that we can use the sample to conclude that about 40% of the school population favors a new parking structure and 60% does not. There you go. Okay. Awesome. The sample proportion, which is kind of like your p hat, this is the percent of your sample, will be somewhat different from the population proportion, which is your p, right? Due to sampling error. What does that mean? Well, you're unable to ask everyone on campus, so your sample size will be different from your population size, which means that you're never going to get a true answer. That's why we call it a sampling error. Therefore, there's no way of knowing how close to a particular estimate is to a population proportion. In other words, we don't know how close we estimate the true population. Over here, I estimated about 40% of the school population favors a new parking lot. But how do I know that for sure? I don't, unfortunately. Okay. So this places the answer, which is 40%. Some doubts on the accuracy of the estimate. How do I know that's really the true value? Maybe it was 70% favors the new parking lot. I don't know. Therefore, we kind of have to introduce a new variable. So statistician prefers another type of estimate called the confidence interval. Confidence interval. Okay? Confidence interval is like an interval between some two numbers that represent your true proportion. You're saying that the proportion will lie somewhere between those two numbers. That's called a confidence interval. All right. So a confidence. So before we look at how we find the confidence interval, let's look at some of the definitions involving a confidence interval. Confidence interval involves a confidence level, which is a percent of confidence. How confident are you that the true proportion actually lies between there? We call that a confidence level. The higher the confidence level, the longer the interval. Okay. confidence level are related to a critical value. In order to find the confidence interval, we need to know the critical value. Well, the critical value is nothing new, it's just the z-value, but we give it a name, we call it the critical value, so don't let that scare you, okay? And also, whenever we make any estimation, there's always an error, right? So the error is found, the error of your estimate is found by using this formula, which is z, and that's your critical value, right? This relates to your critical value, times the square root of p hat times q hat over n. And that's your error in your estimation, okay? Once you have found the error, then the confidence interval can be formed. The confidence interval is taking your sample proportion minus the error, or your sample proportion plus the error, and that is your confidence interval, all right? So let's go ahead and find, let's say we want to find the 95% confidence level. So in the next two examples, I will show you how to find the critical value, because that's pretty important in order to find the confidence. Finding the critical value is important in order to find the confidence interval, okay? So find the critical value related to a 95% confidence level. Here's what I want you to do. Go ahead and sketch a normal curve like this. And I want you to shade 95% so that it's symmetric on both sides. So, I'm going to shade 95% so that it's symmetric on both sides. So shade it like this. So put 95% in the middle. That's 95%. Okay. You want to be 95% confidence. Okay. That means that the let alpha be the leftover from 95, and out of 100 the leftover is 0.05, 5% left, because 5% plus 95% is 100%. So if that's 95%, then the left out pieces is 5%. So these two adds up to 5%. These are the left out piece. If those two adds up to 5%, then that means that each piece on each end is half of 5%, which is 0.25%. So is this is also 0.25%, okay? Now, the goal for this part is to find the critical value. So how do we find the critical value? We were given a confidence level which gets the normal curve. We shade in the 95%. We identify the leftover, which is 5%, and that means that each end must be 2.5%, all right? So what is the z value? Well, here's your z value. Your z value is right here, all right? And this value over here is kind of like your negative z value, but you're interested in the z value, okay? In order to find the critical value, which is the z value, so let's make a note. Critical value is think of it as the absolute value of the z value. Critical value is the absolute value of the z value, okay? How do you find this z value, if you remember? Well, z is related to x, right? X minus the average divided by sigma, okay? That's how you find the z value. But another way to find the z value is when you're given an area, you can actually find the z value if you look it up. So what we're going to do is we're going to look up this area to find the z value, all right? So using a table, I'm going to look up 0.025, and I know it's going to be a negative number. So look up 0.025. You kind of have to look to the middle. 0.025. Where's 0.025? 0.025 is 0.023, 0.026, 0.024, 0.02. Okay. So 0.025 is going to be somewhere in between here. Oh, I'm sorry, that's 0.2. 0.025 is going to be really small. 0.025, that should be right here. See how it's 0.025? Right here. Okay, 0.025. So the z value that's relating to that is negative 1.96. Okay, negative 1.96. So I go over here and I replace that number. So I know my critical value is negative 1.96. But remember, the critical value is the absolute value of the z. So the critical value, we call it this, and it's 1.96. What does this symbol do? This symbol is the absolute value symbol, and it makes every negative number a positive number. All right, very good. Watch the next part of the video, and I'll show you how to do example 4.